Hey guys, sorry I couldn't be here once again, but nevertheless, we'll press on with our lessons. For those of you who aren't at school today, this is still a good opportunity for you guys to keep up to date with the lessons and the work. Today we're going to be going over static electricity, or we are in this first lesson. So static electricity is one of the two forms of electricity we talked about in the last lesson. So the two forms, there is static and current electricity. Static is just confined to one surface. Current needs a circuit to flow through. Okay, so this is revision from the last lesson. Static electricity is when there is a large imbalance of electrons on an object. I said last time specifically, I defined static electricity as the movement of electrons from one surface to another. Sometimes we can just get static electricity without movement of electrons from one surface to another. We can just get electrons all confined into one space. And that is another example of static electricity. So here's a refined definition. Static electricity is when there's a large imbalance of electrons on an object. Here we got one surface being rubbed onto another. So one surface becomes positively charged because there's an imbalance of electrons. There's less electrons. This one is negatively charged. It's got more electrons. And then after that, so this is while it's charged, this is while there is energy in there. After that, we see the electrons returning to their original spots. And in that, we see a large release of electrons. And that is when we see the spark or the little zap that we normally associate static electricity with. Most common example of static electricity, like I said before, is when you're rubbing a hair onto against a balloon. I'll make the screen bigger again. Rubbing your hair against a balloon. Once again, I've got electrons that are leaving my hair onto the balloon. The balloon is now negatively charged. My hair is positively charged. It's being attracted to the balloon. All right. A great way to demonstrate static electricity, which we can't do so today, but maybe we'll be able to use this machine in the future. There's a machine called the Van de Graaff generator. You've probably seen this machine before, maybe on TV or something like that. The Van de Graaff generator has a belt that runs throughout it that separates electrons. So if we see here, there's a belt inside this machine that's taking electrons out of this big metal sphere and moving them along this wire to this little ball here. So this sphere is now positively charged. This little ball here is negatively charged. And what you've probably seen is when some people go and touch this machine, they too become positively charged and their hair sticks on it. And we can do all sorts of crazy things with this machine. So hopefully one day, maybe sometime in the future, we'll actually get to play around with this machine. But what we're seeing here is when an object touches this machine, it too becomes charged. So when a person touches the machine, the entire person becomes positively charged. And that includes every single strand of hair on that person's head. A person touching it will have their hair spread apart because all their hair is positively charged and is moving apart from each other. So the charge has nowhere to go. It's just spreading the person's hair apart. Now, with a Van de Graaff machine, you have the potential of demonstrating static electricity, and that's just showing charge remaining in one place. So here we have a person standing on the machine, and their hair is just standing on end because their charge is remaining in one place. But this person is standing on a plastic stool. That stool is insulating them. And what it's insulating them from is the ground. Now, what you're going to learn as we continue through this topic is that the ground is just like a wire. Ground is a conductor of electricity. It's a really terrible conductor, but it is a conductor nevertheless. Plastic's not a conductor. You can't run electricity through plastic, or most plastics anyway. But the ground is a conductor. So if we took that person off the stool and stood them on the ground, we would see electricity flowing through them, through the ground, and then back into the Van de Graaff machine, which means the charge is not staying in the same spot, and that means you wouldn't see a person's hair stand on end. This would be so good to demonstrate in person, but for now you're going to need to bear with me and stick with these diagrams. Main thing to note is that if charge has remained in one place, it's static, and that's when we see hair stand on end and other things like that happen. The charge is trying to get out of there. But if we take out the insulator, we start getting a current, and so we won't see people's hair stand on end. Okay, so what we're going to be doing today is on style we have a prac that we can do. So this is a prac that you at home, those of you who are at home, can also do as well. There are 5 activities mentioned in this prac. Now you're not going to be able to do all 5 of them. Those of you at school aren't going to be able to do all 5, and those of you at home aren't going to be able to do all 5. You'll have to be doing separate activities. But each activity is aimed to help explain the movement of electrons, and is aimed to help explain where charge is and how static electricity works. So, first prac is, okay, so each of the pracs involve either using balloons or using ebony rods or acrylic rods or something like that. Those of you who are at home, you guys don't have access to ebony rods or acrylic rods. Heck, I don't even have access to those myself. You guys are going to be using balloons, okay? Those of you at school aren't actually able to use balloons just because of not very sanitary to be rubbing balloons on our heads and then putting that everywhere. You guys should get the idea. But, so those of you at school are going to do all the pracs that you can with use of ebony rods instead, okay? So, I'm going to first explain how these ebony rods work. Now, what you're going to notice in general is that rubbing two surfaces together, like any two surfaces together, doesn't create static electricity. It's only specific types of surfaces that help that transfer of electrons to happen. So only rubbing balloons against hair will actually get that static electricity to happen, but rubbing a balloon against another object might not do the same. So what you're going to need to try and investigate is with using a couple of different options. You've got a couple of different options of types of rods and a few different options of types of cloths. Some of these combinations will probably create static electricity, and other options probably won't. I don't have ebony rods and acrylic rods here at my house, and I don't have the same types of cloths, so you're going to need to bear with me for this example. But you're going to need to try taking each example. Take each example of an acrylic rod, each acrylic rod or ebony rod. You're going to take a cloth and vigorously rub the cloth along it until it gets charged, or you suppose it gets charged, and then you're going to need to test the rod out in the different experiments. So each experiment, you're going to test the rod in a different way. I'm going to quickly run through the different ways you're going to test them. Okay, for the first experiment, you're going to be getting your ebony rod or whichever rod, work out the rod that does produce static electricity. You're going to get that rod, charge it up, and then see if it lights up the fluorescent light. So this is an experiment for those of you in class. Those of you at home, you can't really do this experiment unless you have a fluorescent light, which I don't really expect you guys to have. That's the first experiment. You can follow along these different experiments here on the style page. So, second experiment is with electric rods. Now, again, the rods, that's for those that are in class to do, but what you're going to do with the rods is you're going to charge it up and see if they pick up little dry pieces of paper. I'll just make that big screen for you. You're going to see if the rod picks up any pieces of paper. Those at home, you can still do this experiment. Just instead of a rod, you charge a balloon and see the same thing. The second half of this experiment involves charging a rod and then putting it next to a tap of running water. Don't let it go under the tap, put it next to the tap and see what happens. Once again, this will be for the people with the rods. Those with the balloons, don't do the tap one. All right, so all right. Let me guess. So the next part is electroscopes. This is for people in class. The electroscope is a object, or it's a device that helps measure how much charge is in an object. What you're going to do is charge up your rod and then put it up on the area above this disc and see what happens. The fourth experiment is for those at home. You're going to use your balloons to see how they stick on certain surfaces. Rub the balloons and try and stick it on the ceiling and stick it on the wall and see what happens. And the fifth experiment involves moving cans. So I'm assuming those at home, you probably would have an empty can. Look, if you don't have an empty can or a balloon, let me know. But yeah, for this one, you're going to use empty cans and balloons. Those in class aren't going to use balloons, but you still can use the ebony rods. So you're going to charge up your balloon or your ebony rod, put it next to the can, and then watch it move. And the idea behind all of this is I want you to really think about what is happening with the electrons in all of these cases. Which way are the electrons moving? Or what surfaces are they moving to? What things are being attracted to what? Yeah, where's the flow of energy here? So really have a think about that. I'm going to leave a table up on Sector detailing exactly what pracs I'm expecting, or mini pracs I'm expecting people in class to do, what mini pracs I'm expecting people at home to do. And yeah, that's what you're going to be doing for this first period. For the next period, I've got some more basic style questions. I'll leave that up there on Sector as well. But yeah, best of luck, guys. If you have any questions whatsoever, please email me. It's really hard to keep, without being there in class, it's hard to keep being able to be hands-on and help you guys. But I'm willing and able to answer to any emails you send me. So yeah, best of luck, guys.